Welcome to the Federal webinar. We are today going to discuss whether India is capable of manufacturing semiconductor chips. The Indian government last December announced a rupees 76,000 crore or $1,000 billion project, product-linked incentive for semiconductor and display manufacturing. The announcement was part of the ambitious India semiconductor mission that aims to reduce dependence on imports and make up for shortages of the chips. And it comes on the heels of India reaching a target of $75 billion in electronics manufacturing. Well, all this makes for good optics, given the extreme demands of semiconductor wafer fabrication or fab units or chip manufacturing in popular parlance. Can India actually do it? Some 20 years ago, when Karnataka's Congress government under S.M. Krishna had opened itself to the internet revolution and was trying to get as many companies on board as possible, semiconductor giant Intel actually scouted around on the outskirts of Bangalore to set up a manufacturing facility. The project worth rupees 50,000 crore at the time did not take off, as the team that inspected the facility pointed out that the infrastructure required was nowhere near that necessary to host a chip manufacturing facility. Semiconductor fab units, besides huge investment, requires gallons of water for production, uninterrupted electricity supply, high operating costs, and the need for frequent technology upgrades. Semiconductor chips, as all of you know, are used extensively across consumer electronic products, with mobile phones and automobiles leading the pack. Semiconductor is the new oil, with severe shortages crippling the auto industry. One report pointed out that in 2021, nearly 8 million fewer cars were manufactured, bleeding $200 billion worth revenue to automakers, while popular products like PlayStation 5 were in short supply. India's domestic electronic production, as I said earlier, worth $75 billion, requires nearly $15 billion worth semiconductors. And these figures are going up all the time. In the next 5 years, India would need to import nearly $60 billion worth semiconductors. In the last 20 years since the Bangalore attempt, has India progressed enough to set up a fab facility? A case in point, according to media reports, is China, which in 2000 did not make a single chip. By 2020, it had a share of 16% of the world's chip manufacturing, owing to the tremendous push by the Chinese government. But despite such a push, the chips currently being made in the country are not of the cutting edge variety. It still has the way to go before it reaches there. If you look at the world, Taiwan leads the Taiwan Semiconductor Manufacturing Company is the leader in chip making, occupying nearly 52% of the world's market share, followed by South Korea's Samsung with 17%. Then you have other companies in Taiwan, China, the US, and Israel, but all in single digits. So it's not as easy as what we think, because it's really very few companies can do it, and just a minimal number of countries. So it's not something that is like opening any other factory. So, and it also impinges on a lot of other issues related to the country, the making of semiconductor chips. To discuss this very interesting and layered issue, we have assembled a panel of specialists who have been involved in the area of semiconductors for the last several years. M. Shankar Subramanian is the CEO of Chip Test Semiconductors. He's an engineer in electronics and communication with 20 plus years of experience in the semiconductor industry. He has headed the test department of a leading semiconductor company in India for 8 years and has successfully implemented many test development projects for customers both offshore and on-site. Welcome, Mr. Subramanian. Gaurav Goel is a digital design architect with 18 years of semiconductor industry experience. He was formerly with Intel and is currently with AMD India. Welcome, Mr. Goel. Mr. Krishnamurthy is the president and CEO of the Indian Electronics and Semiconductor Association. And needless to say, he's right there on top of the business, constantly monitoring and very much involved in what's going on at the moment. Welcome, Mr. Krishnamurthy. And then you have we have Mr. K. Giriprakash, a senior journalist and formerly with the Hindu Business Line in Bangalore. He's covered semiconductors and the corporate world for the last over 3 decades. And, so it'll be very good to hear how, and he has tracked how this sector has moved from then till now. And we'll hear from him as well. So what we normally do is we please make an opening remark of 5 minutes each, and then we will get on with the discussion. So we can start with Mr. Shankar Subramanian.
Good evening, all. So it's nice to organize this webinar to discuss about the semiconductor push, which is really order of the day. See, although we might have spoken about the same subject 20 years ago or even 25 years ago, it's it to happen. So it's equally important for us to make it happen. And even more the reason nowadays, because of the global changes that we are seeing in terms of the pandemic, where you have restricted travel, where you have something need for doing everything locally within one's own location, one's own country. And apart from the pandemic, the ongoing conflicts that is happening between the giants, various countries, both technologically and politically. We used to, we are thinking, or we definitely know for sure the fact that Taiwan is a leading, in the semiconductor space, or even China is catching up in the manufacturing space. But we all know what is happening, or what is going hot in terms of the Taiwan conflicts between China and US and rest of the globe. Similarly, the ongoing conflict now between the European countries and US and India. So it's more of a necessity. Today, it's more of a necessity to have something available locally. You forget about the capacity, forget about the investment. So it's definitely needed as a fundamental rudimentary thing that's needed for a country's development. So in that sense, at any cost, this should happen. So we have to see how to make it happen, and we know really what are the challenges involved in it. And so it's more of a need today than even 20 years ago, when people only looked at globally available technology, for a cost consideration. Now it's just more than a cost. It's not just a cost. Even if you are willing to pay the cost, there are so many constraints that are happening where you cannot avail certain products or services. So it is much more important to see how we can make it happen, and brainstorm all the pros and cons of what it is. It has its own positives and negatives. Of course, any thing does have these. So we have to see how we have to overcome that to make it happen.
Okay. Thank you, Mr. Subramanian. Mr. Goel, it's you.
Thank you, Mr. Dakshinamurthy. It's a pleasure to be here on this webinar. So you brought up a very important question. You brought up the question about, do we have the ability to make the chips today? And you also mentioned about the anecdote from 20 years ago, when a leading semiconductor company wanted to set it up, but then they threw up their hands for a host of reasons, including political, logistical, and others.
Yeah.
So I would say, sir, to start with, a lot of things have changed in the last 20 years. The first thing is that India right now has a critical mass of people involved in the semiconductor design process. That was not the case 20 years ago. We had very few semiconductor giants in India present at that time. And semiconductor is a very novice industry in India. It all started sometime in late 80s when the private companies started coming to India. But now, if you see, you can name any semiconductor design company or a company like Google, Amazon, etc., who are also trying to delve into some kind of semiconductor design of their own. And you would find that each one of them has an important design center, R&D center in India. There are some aspects of the design process which are exclusively being done in India because of the cost advantage, of course, right? But at the same time, we have made great strides. So as a result, I think the overall ecosystem is far more mature now after 20 years. That's number one. Of course, we can argue that the overall infrastructure has also improved in terms of the road connectivity, electricity, port access, etc. And of course, not all the geographical locations in India would be equally attractive for that purpose. Some places are more friendly for the investment, others are not so much, but that's an individual decision for the company. Secondly, not all semiconductor fabs are equal. So we hear there is a lot of talk that happens about 7 nanometer, 5 nanometer, 4 nanometer chips, right? So you also mentioned about how China is still not on the cutting edge technology, right? Even though they have massive backing from the government, right? However, the most important reason why India should get into this is not to, this is not the space race where we are trying to put our flag on the moon or the Mars. What we are trying to do is simple, pure economics and strategic security. So from that perspective, we are trying to cut down our import bill. We currently import 100% of the semiconductors from outside. We, out of that, 37% of the electronics equipments were imported from China. So we have a huge dependence. So which absolutely, as Mr. Shankara mentioned, we do have to cut down. But coming back to the question of can we do it? So I think yes, sir, because if you look at the PLI scheme that was announced, they are not trying to target the cutting edge technology nodes. It was divided largely into several segments. For example, they mentioned fabs between 28 nanometer to 65 nanometer. They will be given different set of SOPs. Then there are display fabs, there are analog fabs, compound fabs. There are also incentives meant for fabless design companies. So overall, this time, what I see differently is that there is an entire ecosystem that is being targeted. And what is helping is that in the last 20 years, the industry has matured. We do have critical talent in a lot of ancillary spaces. I agree, we still probably do not have the kind of talent we probably need for running a fab if today it were to be built. But I think by the time the fabs do get built up, we do still have like 3 to 5 years of the lead time. I think we should be able to get the right necessary talent. So from the perspective of the fabs, we are trying to target fabs not for cutting edge processors. We are trying to target fabs that will help us reduce the cost of our imports. So typically, a lot of commonly used chips in displays, mobiles, industry, automation parts, if we can manufacture them domestically, that would greatly help. And from that perspective, I think I'm very glad to hear that this time they are not trying to target, fancy sub 10 nanometer nodes, because that would have been foolish. We do not have the capability to do that today. However, right, what we are trying to do today with the 28 nanometer and upwards, I think we do have a good shot. Thanks, sir.
Okay, thank you. Mr. Krishnamurthy.
Thank you very much, Mr. Dakshinamurthy, for the introduction, and also my fellow panelists. I hope you can hear me well.
Yes.
Because we have a torrential rain here in Bangalore outside, so I'm not sure whether the audio is getting background
clear.
noise.
It's
Thank
fine.
you. Thank you. So let me start by answering that question in very simple terms. Can India do it? The simple answer is yes. Should India do it? The second question, the simple answer is yes. Right? There are three very simple aspects we have to consider when you look at the need for semiconductors, the need for electronics, right? India Electronics and Semiconductor Association, which I represent as its president and CEO, covers the entire gamut of electronics and semiconductors. The projected consumption of electronics products in this country by financial year 25-26, that is March 26, will be somewhere in the region of $275 to $300 billion, unless there is another major pandemic catastrophe or anything like that, limiting it. Now, out of this $300 billion of consumption, the maximum India will be able to produce electronic products in this country by 25-26 at the current level of investments and the current level of production will be approximately $100 billion. The semiconductor consumption today is in the range of about $14 to $16 billion. So you take 15 as a mid value. This is going to go up to $75 to $80 billion when we reach $300 billion consumption. So $300 billion worth of semiconductor electronics product consumption, $75 to $80 billion of semiconductor value in that is something which, as you rightly said, the new oil, and growing at a CAGR of about 17% is not something India can sustain even up to 2030. We will have serious financial implications if we do that. So that is, let me park it there, the economics part of it.
Yeah.
Now we will come to the strategy part of it. The geopolitical situation, as some of you have already mentioned, is making it increasingly clear you have no other option. The strategic need for India to be a player in semiconductor and electronics manufacturing, which practically touches every aspect of our life today. I don't think I need to overemphasize that. I think it is pretty clear.
Yeah.
But the more important aspect is the security aspect. It's not only the geopolitical compulsion and the economics, but the security aspects that is embedded inside electronics and semiconductors, thereby is something which the policymakers cannot ignore. Nobody can ignore that anymore, right? And we can go back in time when India made the first nuclear test, the embargoes, and how it affected the Indian technology industry at that time. And then the resilience of the Indian industry to find alternatives, the way the DRDOs at that time worked to overcome that. I think those are all examples in front of us. But the geopolitical situation has changed so much today that unless we take care of it as from a strategy point of view, security point of view, and the economics point of view that I mentioned earlier, the SSC, as I call it, S, S, and E, are the three factors which primarily makes it a compelling reason why India should make semiconductors and electronics and increase its investment in making that happen, right? Now, coming back to the question earlier as to we tried it 20 years back. So let me go a little more in time backwards. In 1985, this country was making semiconductor products, a lot of discrete components. It was also making CMOS integrated circuits with 5 micron technology. In 1986, I can say proudly, when I designed the first ASIC in the country, which got manufactured in a European foundry, the technology node was 2 micron. So 5, 3, and 2. So contemporary technology was 2 micron. India was already manufacturing 5 micron CMOS in Bharat Electronics in Bangalore, right? So we were just 1 or 1.5 node behind the global technology at that time. So is it something that we have done in the past? Yes. Semiconductors complex did come up with some products in 180 nanometer, but due to various other compelling reasons, which some of you are aware of, they couldn't go to the next level of nodes. So what I'm trying to say is, it is not something we are trying to do completely ab initio. There are examples of us trying to do it, and we had reasonable success. So it is not unknown commodity, let me put it that way. And the number of clean rooms that we have in this country today, there are 7 clean rooms of class 10 or class 100 grade. And all of them are in the R&D kind of capability in IISc or IIT Bombay or SCL Chandigarh or in Bharat Electronics, etc. But they all have the capability of becoming a technology center for developing technologies for the semiconductors. And as Gaurav said very rightly, it's a technology intense activity. So what makes it successful, or what will make it successful, is continuous investment in R&D, continuous investment in technology from a manufacturing point, right? I will come back and talk about the ecosystem in the next round of conversation. But it is something where we can feel very confident that today we are much better positioned than we were 20 years ago. And infrastructure, if you ask me, maybe we are not on par with, let's say, what Taiwan has specially created to support semiconductor industry, but it is not something beyond our reach. Looking at the way our road infrastructure has developed over the last 10 years or 8 years, I think these are all problems we can solve in less than 1 year if we apply our. and we select the locations correctly. It all depends on how we pick the place and put our heart and soul into it. All those problems are solvable. So I will stop here. I will talk more about
Sure.
it next.
Yeah.
Thank you.
Thank you, Mr. Krishnamurthy. Giri Prakash, can you?
Yeah,
Your opening remarks.
sure. Thanks, Dakshin, for inviting me for this webinar. A very interesting topic and very, very current. I will take a slightly contrarian view to what the other three panelists have said, because I'm looking at the enormity of the kind of semiconductors that we need to make, the amount of money that is required. I mean, in spite of the fact that the Indian government has rolled out several incentives, tax breaks, and they also said that they will also chip in with some amount of funding. But at the end of the day, there are 2-3 things that are required. For example, we need number one, huge amounts of investment, and technology is ever changing as far as semiconductor is concerned, and therefore you need to keep on pouring more and more money. And the technology has a very high failure rate. Okay, I think the third and perhaps the most important one is that while everybody is coming up with a lot of investment, the US government has said that they will spend $50 billion in chip manufacturing. Taiwan has said $100 billion investment. So at some point of time, and sooner than later, we'll have surplus fab capacity. So my contrarian view is that India shouldn't actually make them. They should focus on parts value chain except fab, which constitutes around 40% of the value chain revenue. And that will lead to two major things. One is a lot of jobs, millions of jobs, and also because there is a low barrier of entry. So they could actually focus on assembling, testing, and packaging, what we call that as ATP. I mean, I'm sure this will lead to a bigger debate, and I throw the floor open for this.
Yeah, I think who would like to take it? Mr. Goel?
Yeah, so I would like to disagree with Mr. Giri here on 2 points. So the first point he mentioned, yes, it is true that semiconductors is definitely requires huge amount of capex investment. However, that is not true for the level of investment required is not same for every type of foundry. So for example, when the 10 nanometer fabs were first instituted, they costed like tens of billions of dollars. India is not trying to do that. If you read the fine print, we are still trying to go with extremely proven technology nodes. Like 28 nanometer is going to be the high end of it. Most likely, I expect most of the process nodes will be in 65 nanometer and 45 nanometer, because that is the sweet spot where your yield is extremely high. So when you manufacture chips, you do not manufacture them individually. You etch them on a wafer. Okay, so on that 300 wafer, because we are talking about extremely small geometries, what happens is there are manufacturing defects, and you need to be able to have enough profits that you can you can offset the losses that are happening because of poor yield. That typically happens when you're trying to establish a new process node, like a 5 nanometer today or a 4 nanometer. Actually, 5 is quite stable these days, but so something like a 3 nanometer or 4 nanometer today. That is what happens with extremely new process nodes. And yes, that is where the failures are high, as Mr. Giri Prakash said. But that is not what we are trying to do. And that is not something we need to do. And this is what I'm trying to differentiate again and again. We are trying to reduce our import bill. We are trying to build a resilient supply chain. And the sweet spot of that, I will say, lies in 45 nanometer, 28 nanometer process nodes. In fact, not even 28. It's good enough if India gets a fab that does 65 nanometer. The bulk of the electronics in terms of volume is still on higher process nodes. The kind of chips that go into automation in industries, in the ones you need for defense, for medicine, for medical equipments, you don't really need any 4 nanometer, 5 nanometer kind of chips today. So that is why, I would like to disagree here, and I'll say, I'm very glad that we are not trying to chase down the geometries here. We are not trying to come up. That's why I said this is not the space race. We are not doing what the US and the USSR did in the 60s and the 70s. We are trying to just get back on our feet. And this is very different from the kind of investments we are seeing from, say, TSMC and other folks. Those are for cutting edge nodes. So even if they do build up a huge amount of surplus inventory, as Mr. Giri Prakash said, that will be for process nodes that does not really help automotive. Today, when we say there is a bad shortage of chips, it is not equal in every sector. It is especially pronounced in automotive sectors. Why? Because automotive guys do not make most of their chips on smaller process nodes. They do not make 5 nanometer, 4 nanometer chips. They do not want to expose a user to a failure happening because of poor yield. They want very rock solid process nodes. And even though automotive is not something that we have primarily in mind, but there is a huge demand for industries that are still looking for chips built on bigger process nodes. So I think even if the likes of Samsung and the TSMCs do end up building surplus capacity, we will still have enough customers coming in from different fields who can still make use of Indian fabs. Thank you.
Just wanted to ask you, if for our reader, what exactly is fab, and how do you, what kind of when you say 28 nanometer meters and then 60 and all that,
sure.
In terms of the cost, would it make a vast difference, or can you just explain what this thing is about?
So let me take 2 minutes to explain that. Okay, so silicon is among the most abundant elements on Earth. So our raw material is practically sand, which is silicon dioxide. It's practically sand, but a very, very purified form of that. We cannot tolerate any contamination. Okay, so from that perspective, we basically make chips from the wafers. But the story of the chip starts many layers before that. So the design, when we say you're designing a chip, you design it using you design it using languages. Okay, that's what happens in the digital space. Analog guys still use schematics. That's a different story. But bulk of the chip is digital these days. That goes through a series of software tools and gets converted into a set of masks. So if any of us have seen how rangolis are made using those masks, that sieves that come, you put powder on it and you get a rangoli. Now imagine chips as they are manufactured using a set of those sieves. The sieve is what the real design is. That is what really defines how the transistors are manufactured on the wafer itself, right? So when we talk about 28 nanometer, 10 nanometer, what we are really talking about is the size of the smallest feature. Okay, to simplify the discussion, I'll say you can think of it as how small the transistor is. Okay, why is that important? Because the size of the wafer is largely standard. So it is still a 300 mm wafer. If my size of the transistor is smaller, okay, if I reduce it by say 70% from one generation to the other, the area of the chip reduces by 50%. That means I can manufacture twice the number of chips from the same wafer. That means I can make more money out of the same wafer, right? There are many other technical reasons why we want to do that. You can make faster chips, you can make more energy efficient chips. There are multiple reasons for that, or you can make smaller ones, right? But so essentially, that is why there is a segment like those who make processors, graphic processors. They are the ones who will always be looking for a cutting edge node. That will be always looking for the smallest size of the transistor, so they can pack the transistors extremely densely to
Right.
make extremely competent and high performing chips, right? But for not everybody really desires that, because there are more manufacturing defects. If your design is going to be more dense, the probability is going to be higher of failure, right? Which is not. On the other hand, we have extremely stable process nodes like 65 nanometer from God knows more than 15 years ago. So they are extremely stable. So from there, many manufacturers that do not really need transistors that small for speed bump, etc., they can live with that.
Okay.
Just to add to what Mr. Gaurav said, Dakshinamurthy, on a simple language to understand this technology for a layman who is not into electronics, it's just like a piece of paper. How thin of a line you can draw on the paper. That is what is the technology. Okay, how thin of a line you can scribe on the substrate, which is the silicon that he is referring to. So that defines it. So how thin we can go, accordingly the density or the packaging or the transistor size that defines. So basically how small of a line connection we can give. So that's the technology. I would side with Mr. Gaurav on what he responded for Mr. Girish's concern about the technology failure and also on the capacity. See, we have to be clear now what we are going after. Are we going after the technology, or are we going after building up a huge fab capacity? Okay, so we should be very clear on that. So I think Gaurav very precisely put that into a good response that we are not looking for high technology. Okay, so we are not doing planning to implement a cutting edge technology or bringing it now, because we know what are the deficiencies we have in that. So now it's more of a at least a raw capability. So we are not aiming for that technology. And again, when Mr. Giri mentioned about the capacity, excess capacity and other things. Again, this semiconductors, we have seen it's a lot of ups and downs. Okay, the automotive recession or the shortage of the electronic supply. If you look at it, why it happened? Because the automotive makers, they just had a control over the chip makers. So they said, hey, if we want, we will buy. If we don't want, we will just stop the order. Okay, that's how demanding they were. And the chip makers thought, hey, we should not do any stock. We should not keep any stocking for the automotive guys, because we end up with so much files. And that is why, it caused a ripple. And now these guys are going after the fab, paying a premium for filling up their thing. So, it is not really about the capacity. It's again about the capability, the capacity can go up or down. But what we need indigenous, like he rightly said, our dependence on others, our reduction of the import bill, where we should not be in a huge dependency level. So that is the target. That is the aim. See, I agree with Mr. Giri that, the other ecosystem is easy to develop. But you take the very typical example of this automotive industry itself. They have all the parts available ready, but they cannot sell the final product because they don't have the chip. So even if one thing is missing, if I can have the assembly, I can have the packaging, I can have the system level design, system level assembly, everything is ready. But there is a huge, bottleneck in the fab. I'm not able to get the wafers fabricated on time, even for a simple validation of the design. We are not talking about any capacity. Maybe now people like Gaurav, there are a lot of design talent has come up, and we are making a complete product. Earlier, design was only an outsourcing 20 years ago, and only that to the back end of the design, not the front end portion of the design. But today, starting from the customer requirement of system level design, the front end design, the back end design, everything is happening. Then it comes to an area where it stops. Hey, now it has to be fabricated. Where do we have not even the capacity? Where do we have the wherewithal to go and try it out? The designers are so keen to check their output, they are not able to do it. So so what we target is what is key. It's not about the technology node. It's not about the capacity. It's not about just doing one part. We need to have the complete supply chain available, at least to a smaller capacity, so that we are taken care 100% indigenous.
Right.
I think probably between Gaurav and Shankara, they covered all the aspects of the topic which Giri mentioned. But to get the big picture clearly understood for the audience, the semiconductor ecosystem, when you look at it, it has 4 or 5 major components. One, of course, is the design, where India has matured over the last 1995 onwards. India started designing, as Shankara said, we were doing a lot of verification, a lot of physical design at that time. But over the last 25 years, it has reached a level of maturity where the entire product gets defined, architected, designed, taped out, silicon received, validated, and declared ready for production. That entire value chain of design is happening in India today. And companies like AMD, where Gaurav comes from, they are all perfected this to a large extent. Now, the second aspect is the wafer fabrication. This GDS goes into a fab where it is converted into on a piece of silicon, on a wafer of silicon, it gets imprinted and converted into multiple dies of the same circuits. So that is a wafer fabrication process. And the third piece of the puzzle is the assembly, test, and package. So that's where companies like Chip Test of Shankara have been working on it for I think multiple decades now. So the ATP or ATMP, as we call it, that is the third piece of the puzzle. Now there are 2 other things which are lying on the outbacks. On one side, it is the materials. So IESA recently conducted a study by an international agency, and we'll be releasing the report next week, actually on 26th rather. And it says semiconductor manufacturing requires about 50 different metals, minerals, gases, and chemicals, right? Approximately 50, out of which 30 of them are available in this country, readily available. Okay, they are not available at the level of purity and quality that is required, but it is used in medical industry, it is used in pharma, it is used in paint industry, it is used in oil industry. So the 3/5 of them are readily available. Another 10 of them can be developed without much investment. So that is on the material side, catering to this semiconductor manufacturing. And this is going to generate huge amount of job opportunities. And I'm not confining this to only Indian semiconductor manufacturing. They can become global suppliers to whether it is TSMC or SMC or Intel and all that. In fact, Ministry of Industries, Government of India, is really now taking this very seriously, because it can give a big fillip to metals, minerals, chemicals, gases. None of them are directly involved with electronics and semiconductors today, but they have the potential to influence the world and generate a lot of jobs. The last one, the last outback, is a supply chain. When I say supply chain, it is the finished product coming out of the ATP, going into a warehouse. From the warehouse, it gets distributed to customers all over the world. Today, any electronics manufacturer orders a component, let's say an AMD processor. Even if it is assembled and tested and packaged in India, the component will be shipped out of a warehouse in Singapore or Malaysia, because our mechanisms of trade and some of the barriers of trade are not that favorable. So the finished product from wherever it is, Taiwan manufactured, assembled in Malaysia, goes to a warehouse in Singapore, and it gets shipped to a customer world over. Now imagine we create that entire warehousing and distribution network out of India, let's say outskirts of Chennai, and it need not be in a big city. It can be closer to the airport, wherever it is, or closer to a port, and the entire infrastructure you create, that will trigger another wave of job generation. Imagine the GSTs and all the other indirect accruals of revenue that comes out of it, the economic impact of that. We have studied all that, and we'll be releasing the report on 26th. We'll definitely share it with all the panelists. But I'm saying, so all these 5 pieces of the puzzle makes the semiconductor manufacturing as an integrated activity. Out of this, the wafer manufacturing is the only one in the middle which requires a significant amount of investment. And I think Gaurav was absolutely spot on to say that we are not chasing that shiny object out there, which is a 3 micron or a 5 micron. And world over, the market share of a 5 micron or 7 micron, even 4 micron product is not more than 15%. What goes into servers, high-end servers or high-end AI systems, etc. But just take one example. India has a target of 180 megawatts of solar power or non-fossil power by 2030. Let's assume 150 of this is going to come from solar energy. One single micro inverter that goes under each panel requires only one chip, and that doesn't require anything more than a 90 nanometer technology. Just imagine the size of the volume of that single product. The power devices that goes into electric traction, what's it called? It's not GAN, but it is the standard CMOS. But there are a lot of power products. Every wall plug that you plug in to charge your phone, all of them can, and then we have 45 million phones sold, 80 million of chargers, because one in the office, one in the home. So just imagine the kind of products that we have demand for, which will all add up to the $300 billion that I talked about earlier. So the number of products that we can identify, which goes into technology nodes, which are about 28, even 45, 65, 90, will probably keep the fab occupied for maybe 50, 60% of the domestic consumption. The remaining will definitely be consumed by the entire southern hemisphere, because remember, if we manage the material, which is sand, the sand abundantly available, the gases and metals and minerals, most of them available, and you manufacture it in India, and distribution also happens out of India, we will be able to shave off at least 10 to 15% on the cost, not the selling price. I'm talking about the cost on each product. Now that will have a huge impact on the bottom line of these companies, and there's no reason why they will not manufacture. So again, I come back to the economics sustains it, India's security needs requires it, and the strategy, so that next time when there is a shortage, our car manufacturers will not be deprived of silicon. And the auto ignition in the scooters, it is a simple 90 nanometer technology, and the design of that, Gaurav will bear with me, it is not very complex. The Indian designers can handle it. In Hindi, they say, "Baएं हाथ का खेल है." It is that simple, right? So we need to understand the context of wafer manufacturing. What is the sweet spot? How the remaining pieces of the puzzle naturally plays into it, and how we have to very carefully construct it. So it is not like, okay, put $10 billion, create a wafer fab, and then see the other things will happen by itself. No. So we need to go and address every component, whether it is material science, design, which is fortunately well entrenched today, the wafer fab, the assembly, test, manufacturing, and packaging, and the distribution network. If we construct it very carefully, I think we have a winning story. Let me stop.
Right. So basically what you're saying is the wafer manufacturing is not the thing alone, but you also have a lot of allied ancillary work. But Giri, you are talking about a value chain which is going to generate millions of jobs. Is this what you were meaning, or can you elaborate on that?
Actually, all the three other panelists have more or less said what I was saying, except that they are looking at niche areas and trying to. I did talk about chip design, assembling, testing, and packaging as areas to look into. I also talked about the fact that about value chain revenue. So in many ways, I do agree with them, because of the fact that this is exactly what India should be looking at. But I think at the end of the day, what is also important is that we need the kind of investment that needs this kind of manufacturing capacity. So do we have that kind of manufacturing capacity? Will the government continue to give incentives? But given the kind of track record the government has, over a period of time, one sees that it follows a policy of where it gives a lot of incentives, but when it comes to actual implementation, something else happens. I mean, you talked about startups. We have talked about a lot of other industry. We have talked about creating an ecosystem for the automobile industry. We have talked about how there are zones for textile, for a whole lot of other industries. But you find that they're all set up across the country. And when you go there, you find that there are just those boxes available there. Nobody talks about incentives any longer. Every government changes, comes up with new fiscal policies, comes up with new incentives, but they don't get implemented. And here, I think, as far as semiconductor is concerned, the government actually needs to put a lot of effort in it, because we have the engineering capability, we have the talent. What we need is constant incentive from the government. And, and also, whenever the industry goes through a cyclical process, you need a helping hand from the government. I think that is something that we should look at as far as big picture is concerned. I do agree that we have all the capabilities, and maybe we can look at niche areas as well.
Yeah.
Mr. Giri, I would agree with you about this. The government support, which is really needed for the industry players to withstand any cyclical conditions or any turnarounds. But it is not going to happen purely because, see, that's where our model in India is proven to be distinct or different from other countries. If you take different countries, the government play a key role even in terms of the control of such companies. Not only just investment, they also have a role they have a stake in the running of the companies. They have a stake in terms of the amount of investment that they have put in and the control that they have. But it's in a way good and in a way bad, and it depends on what suits us. Basically, in India, as you rightly said, irrespective of the government, the companies should run. So it should not be too much relying on the government policies per se. I mean, you take some of these, the service companies, IT companies, where they make IT products and other things. They are not too dependent on any, the government incentives. And they have been taking it was more of a debt-based funding that they start with. Then it's more of a, putting of the funds generated from the operations into development, R&D of new products and coming in. So I still remember in the early 90s, we had so many, manufacturing units from the government, like the ITI units in various 5 places. I visited them. Beautiful facilities, infrastructure, clean room facilities. Although it is not for the fab, but still they produce some of the technology came from Alcatel. Okay, they were the E10B exchange systems that they were producing. The Hindustan teleprinters, HTL. Some of those phones, even the private players like Tata Keltron used to build it. BPL, we heard about it for the TV. They built the codec devices. It was such a mixed signal device, which was, they just bought the wafers, from Hitachi, Motorola at that time. These players, Indian companies, although it was done by government, they bought those wafers and they designed all that based on the technology, royalty that they paid to such global consumers, and they were selling so much of systems internally. So the manufacturing is strong, and even the investment at that time was huge for that level of economy that it was in the early 90s. So we have to be careful in terms of the investment, and this is where I feel that we have to pick an existing player, maybe globally, who is willing to cater to the Indian market by co-developing with an Indian partner. Maybe they move some of their, as Mr. Gaurav was saying, see, there are target applications, right? Consumer applications, automotive applications, defense applications, aerospace applications, like power products, which Mr. Krishnamurthy was saying. There are different applications. So whatever applications that they are not doing it more economically, effectively in other places, they can transfer to try those nodes of technology in India, okay? Try to make use of that. And the good thing I could see in the policy is, 20 years ago, all these policies defined as all the incentives, everything capex only for new equipments. I was really surprised when I saw this time. It did make a mention of the used equipments also, which is a big change in the government's perception of these used equipments, valuation of those equipments. So even if they transfer some line from elsewhere, and that is where that portion alone, the government should give them a good incentive of why they should move it from there. And it's just a beginning. And that seed, that will, once it kickstarts, then, it will automatically, regenerate itself for taking care of the further development. So incentive wise, depending on the government alone, I as a private player, I would say it's too risky.
No, I know, I agree with you on that. But look at the software industry, the software services industry. One of the greatest success stories of India, and that's primarily because of the fact that government never interfered. Here, the government is actually, I'm not talking of interference, it's actually helping with, and trying to incentivize the semiconductor, the manufacturing. And the good part is that they're actually going ahead and doing it. The bad part is that I do hope they continue to do it.
Well, Girish,
I think for me, that is far more important as far as manufacturing is concerned. Let us look at the automobile industry, for example. If you look at the automobile industry, what did we do? We now have we had gasoline-based engines. Now they decided that they will give a lot of incentives for electric vehicles, but they missed out the middle part. That's the hybrid. Whereas it should have transitioned from gasoline to hybrid to electric vehicles. Now we jumped from one to the other. And now we find ourselves that we haven't created an ecosystem at all. Whereas the government of India is saying that we are going to give you this incentive, that incentive. Unfortunately, the automobile industry is not able to cope up with it because the transition has not happened in a logical manner. Now, for me, that is the part that I'm worried about.
Yeah, Girish, you are absolutely right, because that's why I use the word, this has to be very carefully constructed. But, piece by piece, we need to look at each of the components that makes the entire ecosystem, and it has to be constructed carefully. Otherwise, we will run into the same problem that you are mentioning. And software industry, despite not being capital intensive, still government gave 10-year tax holiday under the STPI scheme. And that is probably what brought all the big MNCs to India, because they saw that this is a huge cost arbitrage that will create. And then, of course, the good part is talent was available, or talent was created, very, very well. And then also compare with the government support to Indian Space Mission or Space Commission and the Atomic Commission that we have, where government has interfered, invested, but at the same time given enough autonomy to make them successful. Today, the most two of the bright shining stars of Indian technology sector is the Atomic Commission or the atomic sector and the space sector. Both of them have succeeded phenomenally, despite being under the government umbrella for a very long period of time. But the trick lied in those supporting, they took their hands off from day-to-day management. And in fact, I don't know whether I will offend anybody by saying these are the two institutions where a cabinet additional secretary or somebody is not sitting at the top. It's a technocrat who is sitting at the top of Atomic Commission, who is also the atomic secretary. In coming to space, it is the ISRO chairman who is a DOA secretary. So involvement was very high, but interference was minimum. So the models are available, right? So
I agree with you. Models are available. I completely agree with you.
We should construct it carefully with the right model, then it will happen. But if you also make the past mistakes, then it will have its own ramifications.
There is one question from an audience. The question is, but don't you think technology breakthrough happens only when you think big? When we know we have the talent, why play safe? We are back to gradualism. But our consumers are smarter. They are able to jump directly to cell phones, skipping PCs. You can say, so how do you see this? This kind of a gradual movement into, what is cutting edge.
So, Mr. Dakshinamurthy, sometimes you do need to take baby steps before you go for a sprint. That is how I'll say it. So currently, we do not have the manufacturing, commercial scale manufacturing capability here. So we first need to establish that. After we have done that, are we going to go through the same cadence that we have seen in the industry from 90 to 65? No, that is not necessary. And also, again, we are not trying to get into a space race with, say, China or South Korea. We are not trying to do that. We are ensuring that we can be self-reliant, we can cut down our imports. So yes, so there is absolutely no shame in trying to stick our, to go with an older technology, I think it makes more economic sense right now.
So there is a
Dakshin, I would like to make a point here.
Yeah.
This talk about this. Let's jump from one to another. So there is a two-wheeler manufacturer which is completely into electric vehicle manufacturing, two-wheeler electric vehicle. So what this company did was that it bought a European-based two-wheeler company, design and everything and all that, and then brought it here, and they did whatever that was required to make it a very Indian kind of product. Finally, what happened? One fine day, you saw some of these two-wheelers going up in flames. All right. But there's another two-wheeler product company which did not do it, which started from scratch. Everything was customized for Indian conditions. That two-wheeler company is actually doing well. So therefore, we had to, as one of the panelists said, it is very, very important that whatever that we do it in a manner that suits Indian conditions, however much time it takes, however much investment it takes. Jumping from one technology to another without going through the challenges and the difficulties of, this kind of a chain will lead us into bigger problems.
Right. In fact, there's one more question for Mr. Goel. So your suggestion is to ignore high-end chips that are used in, say, smartphones, but go for industrial consumer electronics, etc. So this issue, you spoke about the sweet spot. So what exactly is that sweet spot that you're,
So as Mr. Krishnamurthy mentioned, right, the volume that the extremely high technology nodes sell, it's only 10 to 15% of the overall chip volume. The bulk of the chips that are still currently used in India, if you see, right from every chip that is used for a mobile charging device. So most of them are still manufactured on bigger technology nodes. So that is why if we are trying to manufacture those, we can make profits, sufficient profits, keep our fabs running, generate sufficient jobs, and cut down our import bill. So especially on the topic of jobs, I'll say, so it is not just the device physics folks who will be getting the jobs once the fabs come here. There are a lot of software guys who will get the jobs, a lot of chemical engineers, mechanical engineers, production engineers, sales, manufacturing, a lot of blue-collar workers are going to get the jobs when these humongous fabs are created. So it is a huge step. So it is. So I know we have a tendency of comparing with the software industry and how it went. And yes, I agree. Software industry, what really helped was the fact that there was very little investment required. The government gave huge tax breaks, but the government is giving tax breaks here and has traditionally given this across the world. For example, in case of Taiwan, TSMC was practically created by the Taiwanese government. The founder of TSMC was brought in from US, Maurice Chang, and he was asked to lead it. The same is the case for the China-based fabs. So the government has been backing them. I agree with Mr. Giri Prakash when he mentioned that we should not have that we have a change of regime and there is a change of policy. I completely agree with you. And while the government, for example, talks about this is a 20-year roadmap, the 20-year roadmap must stick irrespective of who is governing Delhi. And that is why the continuation of the policy is extremely important. But at the same time, I'll also say, thankfully, we have seen a couple of examples where the policies have not changed despite the change in the governments. For example, when the liberalization happened in 1991, thankfully, that has been continuing. We have seen governments from all fronts of ideology. Thankfully, that is still continued. So I'm just hoping that we do not see setbacks just because we see change of government.
Okay. There's anyone else need?
Yeah, say out of the total market share of $450 billion worldwide in this financial year for semiconductor market, $350 billion came out of non-FinFET nodes, that is above 16 nanometer technology, that is 22, 28 and above, was $350 billion, $370 billion. Only about $80 billion was this revenue share of all the products below 16 nanometer. Forget about 3 and 4. So 16, 12, 10, 7 and 5, all put together was about $80 billion. $370 billion of revenue was assigned to or is attributable to the non-FinFET 28 nanometer and above technology node. So strategy-wise, I think Government of India got it right. Incentive-wise, I think the greater incentive for silicon fab, display fab, and ATMPs, I think that strategy got it right. And the India Semiconductor Mission that has been created now with the international experts. And again, I didn't see any government of India person sitting on the top of the ISM. It is going to be headed by an expert. So I think they are getting the pieces of the puzzle correct. IESA was very actively involved when this policy was made. Almost 1 year, we were working hand in hand with the government in identifying all the finer nuts and bolts of the policy. So I think they are getting it right. And even if, let us say, theoretically, hypothetically, it can always happen, there's a change of government, the chances of this becoming completely irrelevant, I don't see that happening at all. Because, the foundation has been properly thought through, is my view and opinion.
Right. There's one more question from a viewer. He says that I work closely with the semiconductor industry in Bangalore. Do you think that the government can supply 24 hours electricity for the fabrication plant? Incentives come later.
Well, I would see we had multiple discussions, and it's a very, very good question. So when it comes to the basic infrastructure, there are 3 things that are required or 4 things that are required for a successful operation of a semiconductor manufacturing ecosystem. I'm not only talking about the wafer fab, the entire manufacturing ecosystem, and most of the design companies, including the one to which Gaurav works for and I used to work for, we all used to have our own captive, uninterrupted power supply backups in case the power fails, so that we don't lose even a minute of downtime. Now, the bigger state, and this is a heavy lift kind of activity, semiconductor manufacturing. So the bigger states who are vying for it, for example, Tamil Nadu, Karnataka, Telangana, they all have assured, at least on paper, that they will create a separate power infrastructure grid for the semiconductor manufacturing, because it took us about 3 to 4 months of education process, why it is very, very critical. Then comes the next question of 10 million, assuming that we hit the global standards of 40,000 wafers per month as a capacity in whichever technology node we make the manufacturing, it requires approximately 10 million liters per day, 10 MLD of water, and good grade water. It is recyclable is perfectly fine, and good grade water, and the sources and the availability has been confirmed. So yes, do we have it today? Probably not, but can we get it there? Yes. The third one is customs and ease of customs processes and raw materials coming in and going out. So I would like to share the same example which Dakshinamurthy sir talked about. Somebody coming here and looking at 20 years back. In fact, I remember as a member of the industry body, I was present in some of the meetings, and they had a very simple, and they had done their homework very well. They said the wafers will come out of Taiwan fab at 6 p.m. at the end of the shift. We will put it on a plane at 10 p.m., bring it to one of the leading airports in India by 5 a.m. next day morning, India time. I need to have these wafers reach the assembly house by 7 a.m. when the India shift starts. And the entire dicing, assembly, test, packaging, marking should get completed by the end of shift at 6 p.m. And 10 p.m. same night, it should be back in your airport where my cargo plane will be waiting. And next day morning, 5 a.m., it will be in the Singapore warehouse. So from the time the wafer leaves Taiwan fab at 6 p.m. to the time it reaches the warehouse at 6 a.m. the third day, it is 36 hours. So that's the kind of, and until that happens, it is a dead inventory. The moment it reaches the warehouse, it is dollar. You see the economics. So, right. So these are all the finer aspects we have to understand, splice it very nicely, and make sure that whatever is missing today, is constructed so that this whole food chain happens in the right way. So this is where I keep coming back. We have to construct it very carefully to make sure that all this happen the way the world expects it to happen. We cannot say, no, this is what we have, do it, it will not happen. This is what you want, we create it, then it will.
Right. One question that really arises is that 20 years ago, coming back to the same example, you had Intel coming and doing the check and saying not suitable. It's 20 years have gone by. So what can you do in the next few years, which we were not able to do in the next 20 years? I mean, why has there been any kind of progress? Yeah. Yes, Giri.
Well, I think we have made progress. For example, the connectivity from the international airports to the nearest, cargo complexes are definitely much better than what it used to be. The customs processes are, definitely far better. Of course, this is not something where you can come in and plug in tomorrow. Certain amount of continuous education process has to happen. Now, starting from the time criticality of it, why it needs to move out, or we create a bonded, virtual bonded warehouse like STPI created for the design houses, where we could bring into an STPI location capital equipments without any duty requirement, but it is bonded. So there are structures that can be created to overcome some of the impediments that we have. Again, we don't have everything today, but the moment we say this is D0, from that, I don't think it will take more than a year for us to go and construct what we need to get. That is my view.
Yeah, I'll just add one sentence to what Mr. Krishnamurthy said. When TSMC started in Taiwan, they did not have all the pieces of the puzzle in place either. It was a developing country at that time. It was not a fully developed country. So if they can do it, so can we.
Yeah, absolutely, Gaurav. Absolutely.
Yeah.
No, also,
I have one question to.
Yeah.
Can I?
Yeah.
Can I?
Sure.
I'm sorry. Space, the kind of progress that we have made is something that's extremely laudable, and apart from that, it's completely government owned. So here, I would like to come up with two issues here, and I want panelists to actually discuss it. Now, you might think that we are slightly going away from that topic, but I would still want the panelists to discuss about that. Number one is about HAL, government owned, very successful company, but suddenly it got starved of contracts because there were private companies which the government said it should be open to them as well. So what happened to HAL? Now, the other thing is, while software services industry is done remarkably well, why is that our track record as far as software product is concerned has not taken off so well? We are struggling with the GST issues. We are struggling with income tax portals. And we need a very good answer as far as software product is concerned. We haven't seen that kind of success. I would like the panelists to discuss that and then associate with the current topic that we are discussing.
So the software products, I think, Mr. Giri, we have indeed developed a lot of software products. You take the case of Zoho or any other local company also. They have developed a lot of indigenous software products that are being sold. It's not just service alone. It's not just the application development alone.
There are the big ones. But software services has been there for a very long time.
The issues
but as far as software product is concerned, we don't have a good record. We have small here and there. I agree. We have a banking software which keeps has full of holes. But look at the other ones. We don't have big ones. Like in spite of the fact that this has been there for such a long time.
See, it is not a standardized product that they sell. See, in software services, whatever products that they develop are actually solutions which are very custom made, because it can be the same process, but different players in the same industry use it in a different way. So that is why, in fact, they are growing. The reason for their growth is because they don't really standardize it across the companies in the same sector. They just produce the custom built solutions that is, required for each of the entity, within the same industry. So that is why you can't really see them as a standardized product that they sell as a product. And the other technique is also economies wise, when you call it as a new solution, every time you make money out of that new solution rather than a standard product that you can sell. Okay. So see, the issues that we are seeing with the portal, the GSTs and other things, it's purely the operation deficiencies that I would say. It is just in terms of translating the requirements correctly. because in any IT solution development, it's more of the application definition which is a key. See, the software guy or a design guy even here, they will know purely about their technology, their techniques, okay, their software tools, their programming methods. But how it will be, how it has to be written for the application need, that's why even when you compare it with electronics, there is always a system level, definer, product who defines the product, that this is how the product has to be to meet the customer requirements, and based on which only the design team will work. So those are the key guys. So which is why, the pitfalls happen.
Okay, so go ahead.
And I think, Mr. Giri, I agree with you. We had such embarrassing state of the income tax portal, but at the same time, we have also implemented UPI infrastructure, and that is definitely world class right now. So yes, I agree with Mr. Shankara. We have to get the operations right. We have to get the right set of requirements and pass it on to the right set of people. But I don't think that really reflects on our capability. I think as far as the capability is concerned, the very fact that we made our own indigenous supercomputers and we have a supercomputing mission right now, I think that reflects well on our capability as far as the technical prowess is concerned. There are more issues involved, for example, in terms of funding, etc., etc. And yes, and that is what we need to ensure that, yes, at a policy level, it's a good policy, but we need to ensure that this eventually becomes a success. And there are several players that need to cooperate to make that happen.
Right.
One simple example to amplify the point which Gaurav was making, the meter reading software which is used by the electricity boards in this country, and printing the bills instantly, this has been developed over a period of about 7-8 years by one small company. And today, I think 22 out of the 30 states in the country use the same software. It is not a branded, like Microsoft Office, there is no branding for that product, but every state, every meter reader carries a product with the same software embedded in it, of course, in different languages and all that, depending on the local needs. That is one example. Then the other example, the UPI thing, which Gaurav talked about. Now, even the point of sale product, where you see it in all the supermarkets and in all those places, they are all available in Indian languages and they are all developed here, right? So again, the crux of the issue lies how well you define it first time right. If you define it right first time, you get it right first time. Otherwise, you learn through a few iterations, but finally you get it, right? So there are n number of examples where software product development has happened, getting deployed, used, and some of the examples that we talked about.
Right. One more question is, what is it that Taiwan has which we don't have? India is is it a, what is it? I just leave that to you.
See, it is just the location advantage plus the complete ecosystem that they try to build in. Okay. They have even the PC or the laptop manufacturers available there. They have all these PCB manufacturers there. They have all the wafer fabs there. They have the assembly and test manufacturing there. So the complete supply chain of manufacturers are there in the same,
No, I agree with you. They have it there, but they've created it. I'm asking why.
Correct.
They have been able to create it, and why not India?
Yes, absolutely. Wonderful question. So TSMC started out of a small lab, R&D lab called ITRI in Taiwan. It was like a lab project, which then finally grew into a global behemoth, right? But then they understood, probably Maurice Chang was able to define every piece of what goes into it very carefully, as I said earlier, from the basic material all the way to the end finished products, and what is required for it to move globally without any boundaries. I think that definition part of it, they got it absolutely spot on in the 1.5 attempts, I would say, not even 2, 1.5 attempts. If you really trace the history, you'll find that even before the second revision was done, they got all the pieces of the puzzle correctly defined. So there is nothing that is, and in fact, Taiwan depends globally for all the metals, minerals, sources, gases, etc. They don't have any of them in that case. They import everything. So that's what I said. If we can even get 30 out of 50 available in the country, and we do a wafer fab and we run it successfully, our cost per product will be 15% less, and cost of the product. Selling price, it may be quite different later. That depends on the economics part of it. So the cost arbitrage, even in manufacturing, and take the case of ATMP, the assembly test, etc. Our diplomas and ITI people can be very well trained in a very short span of time. A couple of companies who are already put in the bid or proposals, I would say, for this scheme, they have evaluated that in about 6 to 9 months' time, they will be able to train most of our diploma holders and ITA holders to do the assemblies, the packaging operations, the test operations, test development, etc. So the talent is available, right? So we will be able to make an impact in the ecosystem is our strong belief.
Right.
They made it as a backbone, Mr. Dakshinamurthy. In Taiwan, they developed the semiconductors as a backbone. Here in India, we didn't perceive it as that way. We have too many other areas that we still think that is our backbone, and which is bringing a lot of the currency, into the country also, and overall economic growth. So it's evolving. It's not
a priority. That's what you're saying, in other words.
See, left to the industry, they will figure out some of the finer aspects. And I because you are based in Chennai, I would like to take a very simple common man's example. One of the finest quality silks are made in Kanchipuram. Now, there are silk sarees worth a lakh of rupees, which is your 2 nanometer, 3 nanometer equivalent of technology. And there are those which are in the 3,000 to 5,000 or 6,000 rupees bracket, which is your 28 and 65 nanometer technology. And who taught them what they should make when? They figured it out, right? The market taught them. And I always go back to this was my favorite example, Kanchipuram silk sarees versus and the semiconductor, because the finer geometries, the finer prints, the finer designs, the intricacies, all pushes up the value. Right? But then they don't make tens of thousands of them. They may make during the Diwali season and marriage season, maybe they make 1,000 of them. So the remaining ones, the market dynamics teaches them what is the right mix. Right? And they get it right.
Yeah.
It's a goal. Yeah.
And Mr. Dakshinamurthy, the other thing I want to mention is that TSMC was not this big a behemoth as it is now. 20 years ago, it was one of the important foundries. But what happened is that the cost of dealing with foundries went up exponentially high. A lot of design companies, they eventually realized, hey, I should just stick to design and let me outsource manufacturing. And that worked out wonders for pure play foundries like TSMC. So they were on the right side of the history.
Right.
See,
we shouldn't just look at saving foreign exchange. We should also look at increasing our foreign exchange, earning more foreign exchange. We have software products, we have these kind of products in India, but how many of them are bought by the rest of the world? I mean, China is the factory of the world. Do we have something which is similar here? We should build large scale, as one of your viewers talked about. We should actually build world-class products. We should be able to use that to earn more foreign exchange. I think finally, that's also far more important than what we are doing for the country, because our products would have gone through that kind of test when it becomes a world-class product. So I think the focus should be on that as well.
Right. Yes, Mr. Krishnamurthy, you wanted to.
Now, I was saying that, a medium-sized fab with a capacity of 40,000 wafers per month requires about 60, 70 acres of land. Even in the lowest price point place in US, if you take the Midwest, the hardcore Midwest of US, and compare it with the outback areas of Chennai and Bangalore, it will be still maybe 4 times cheaper, right? So if you purely compare one-to-one capital that gets invested, which will finally translate into the bottom line of your cost price of the chip, I think India offers that advantage. Labor cost arbitrage, India offers that advantage. Now, if you are able to export the materials, metals, chemicals, which is $100 billion market by 25-26, even if you are able to get 30% of that, we are talking about $30 billion. And if you are investing $10 billion or $20 billion, and are able to generate $30 billion worth of revenue outside of the semiconductor product ecosystem, I think we are talking about sitting on a winning combination. But we have to be very careful. We should not go all over the place. I think Gaurav was very spot on right from the beginning. Pick the spot, pick the sweet spot, invest in the right place, and then I think over a period of by the end of this decade, we should be able to get ROIs in the positive in the investments that you make.
Let me draw a parallel with the software industry. When we started, people started coming to India for the reasons such as pricing. Okay, it was cheap, right? We did not probably offer as much value as we do now, but we have slowly gone up the value chain. The number of startups that we have, the number of unicorns that we have out of India, they have grown exponentially. But to reach there, we had to start somewhere. And I'll say we are pretty much at that stage right now. Our design, verification, etc., as Mr. Shankar and Mr. Krishnamurthy mentioned, we are no longer at that state where people just outsource things because it's cheaper in India. If you want to get things cheaper, you should go to East Europe now. You should no longer come to India, honestly speaking. So people come to India now because we have moved up the design chain. We can do an entire chip ourselves as far as the design is concerned. We did not have that capability. And that ways, once we start manufacturing in India, even though we will start with something very humble as how people see it, we will eventually move up the value chain in a decade or so.
Right. I mean, paradoxically, Gaurav, companies who are looking at East Europe now for cost arbitrage, that option also has gone up in smoke. So now they are stuck with India for value and cost advantage, both, right? I mean, there were companies who were looking at Armenia and Poland and places like that. Yeah. They all have put that plans in back burner after the recent flare-up. So sometimes things work to our advantage, whether we want it or not.
Right. It's just a last question. A very brief answer. Where is the potential Taiwan hiding in India? Which part of India you think is the potential Taiwan?
As an industry association representative, I will not answer that question in one state or other. Tomorrow morning, I will be flooded with phone calls from different state secretaries, IT secretaries. So I wouldn't venture to that. But the major states are all potential candidates.
Right. We are having many Taiwans within India.
Yes, there are many Taiwans.
I'll say any coast, a coastal state has an advantage because of access to port. There are many coastal states that have good road infrastructure in the peninsular region. And so I think there are many potential states. I also don't want to name any.
What's your take, on this?
Sorry?
Hello.
You're
I was asking Giri Prakash if he has any view on this. Yeah, on a potential Taiwan.
I mean, any state in India. There is no lack of talent. Indians are extremely talented, hardworking. We just need that kind of support from the government, consistent support from the government, and complete no interference with the bureaucracy. So I think whatever the other panelists talked about will all become a reality if these things are set in place. So every state has a potential to be another Taiwan.
Okay, that sounds really very positive, and I think on that note probably we'll end the discussion. Thank you all for joining the discussion. Thank you so much.